This is the EdExcel A-Level Maths Paper 1 from the 2023 series, and in this paper we will be taking a look at the pure section. Question number 1. We have to find the integral of x to the 1/2 multiplied by 2x subtract 5 all over 3 with respect to x, writing each term in simplest form. We need to write this integral in an integrable form. So we have x to the 1/2 multiplied by 2x subtract 5 over 3, which we can simplify. What this integral is equivalent to is the following. We have the integral of, well, here we have x to the 1/2 multiplied by 2x, which is 2x to the 3 over 2, and then we divide this by 3, and then we subtract x to the 1/2 multiplied by 5, which is 5x to the 1/2, and then we divide this by 3. So we are integrating 2x to the 3 over 2 over 3, subtract 5x to the 1/2 over 3 with respect to x. So let's work this out. Well, if I add 1 to the power, x to the power of 3 over 2 plus 1, that's x to the 5 over 2, and then I need to divide by this new power. So we have 2/3 divided by our new power of 5 over 2, that's over 15. So integrating 2x to the 3 over 2 all over 3 is equal to 4x to the 5 over 2 over 15. And then we subtract the integral of 5x to the 1/2 all over 3. Well, if I add 1 to the power, x to the 1/2 plus 1, that's x to the 3 over 2. And now we need to divide by the new power. So we have 5 over 3 divided by 3 over 2, which is 10 over 9. So integrating 5x to the 1/2 all over 3 is equal to 10x to the 3 over 2 over 9. And don't forget, when we integrate an indefinite integral, we need to add on a constant c. So integrating x to the 1/2 multiplied by 2x subtract 5 over 3 with respect to x, we end up with 4x to the 5 over 2 over 15 subtract 10x to the 3 over 2 over 9 plus c. Question number 2. F of x is equal to 4x cubed plus 5x squared subtract 10x plus 4a, where x is a real number and a is a positive constant. Given that x subtract a is a factor of f of x, for part a we have to show that a multiplied by 4a squared plus 5a subtract 6 equals 0. So for part a, if x subtract a is a factor of f of x, that means f of a is equal to 0. So what we are required to do is replace the x with a and then set that expression equal to 0. So we have 4a cubed plus 5a squared subtract 10a plus 4a equals 0, and negative 10a plus 4a gives 6a. So we have 4a cubed plus 5a squared subtract 6a equals 0. And each term contains an a, so what we can do is factorize out an a. So we have a multiplied by 4a squared plus 5a subtract 6, and this is equal to 0. For part B, for the first part, hence find the value of A. So for part B, for the first part, to find the value of A, we need to solve this equation here. And for us to solve this equation here, what we can do is factorize this quadratic 4a squared plus 5a subtract 6. So we have a multiplied by, well, if I factorize, we end up with 4a subtract 3 multiplied by a plus 2. And this is equal to 0. And if we solve, we have a equals 0. We also have 4a subtract 3 equals 0, in which case a is equal to 3 over 4. And we also have a plus 2 equals 0, in which case a is equal to negative 2. So we've got a equals 0, a equals 3 over 4, and a equals negative 2. So a equals 3 over 4 is our only solution, and that's because a is a positive constant, it's greater than 0. So a is equal to 3 over 4 only. We now have to use algebra to find the exact solutions of the equation f of x equals 3. If we think about what f of x is, that's 4x cubed plus 5x squared subtract 10x plus 4a, but we've already found the value of a to be 3/4. So we know that f of x is equal to 4x cubed plus 5x squared subtract 10x plus 4a, and we know that a is equal to 3 over 4, so f of x is equal to 4x cubed plus 5x squared subtract 10x plus 4 multiplied by a, so we multiply this 4 by 3/4, and 4 times by 3/4 is just 3, which means f of x is equal to 4x cubed plus 5x squared subtract 10x plus 3. And what we are required to do is solve the equation f of x equals 3. So solving the equation f of x equals 3, we have 4x cubed plus 5x squared subtract 10x plus 3 equals 3. The 3's simplify to 0 on both sides, and therefore we have 4x cubed plus 5x squared subtract 10x equals 0. Each term contains an x, so we can factorize out an x. So we have x multiplied by 4x squared plus 5x subtract 10, and this is equal to 0. And what we are required to do is solve this equation. Well, clearly we see one of the solutions is x equals 0. To find the other two solutions, we are required to solve the quadratic 4x squared plus 5x subtract 10 equals 0. From our calculator, if we go to the menu, then the equation sub-menu, we have a polynomial of degree 2. We have 4x squared plus 5x subtract 10 equals 0, in which case we see x is equal to negative 5 plus square root 185 over 8, or we have x equals negative 5 subtract square root 185 over 8. So we have x equals 0, or x equals negative 5 plus minus the square root of 185 over 8. Question number 3. Relative to a fixed origin O, the point A has position vector 5i plus 3j plus 2k. The point B has position vector 2i plus 4j plus ak, where a is a positive integer. Part A, we have to show that the absolute value of OA is equal to the square root of 38. So for part A, the absolute value of OA, that's equal to the square root of 5 squared plus 3 squared plus 2 squared. And if we work this out, 25 plus 9 plus 4, that's 38. So the absolute value of OA is equal to the square root of 38. For part B, we have to find the smallest value of A for which the absolute value of OB is greater than the absolute value of OA. So for part B, we are finding the value of A for which the absolute value of OB is greater than the absolute value of OA. Let's begin by finding the absolute value of OB. We have the square root of 2 squared plus 4 squared plus A squared. And this will be greater than the absolute value of OA, which we have just worked out to be the square root of 38. And if we square both sides, you will find 2 squared plus 4 squared plus A squared is greater than 38. So if we work out what we have, well, A squared is greater than 18, and if we attempt to find the critical value of A by working out the square root of 18, the square root of 18 as a decimal is 4.24, etc., which means A is greater than 4.24, etc. And as A is a positive integer, we can therefore conclude the smallest value of A for which the absolute value of OB is greater than the absolute value of OA is 5. And that's because A is a positive integer. Question number 4. The curve C has equation y equals f of x, where x is a real number. Given that f dash of x is equal to 2x plus 1/2 cos x, the curve has a stationary point with x coordinate alpha, and alpha is small. For part A, we have to use the small angle approximation for cos x to estimate the value of alpha to 3 decimal places. For part A, because we have a stationary point, we have to set f dash of x equal to 0. And we have a stationary point at x equals alpha, so we have f dash of alpha equals 0. So we have to set the 2x plus 1/2 cos x equal to 0 with x equaling alpha. So we have 2 alpha plus cos alpha over 2 equals 0. And at this point we need to use the small angle approximations. We know that cos theta is approximately 1 subtract theta squared over 2. And so using that, we have 2 alpha plus 1/2 multiplied by cos alpha, which is approximately equal to 1 subtract alpha squared over 2, and this is equal to 0. So let's try to simplify this. We have the 2 alpha, and then we have 1/2 times by 1, which is 0.5, and then we have 1/2 multiplied by negative alpha squared over 2, which is negative 0.25 alpha squared, and this is equal to 0. Let's now attempt to solve this equation. From our calculator, if we go to the equation sub-menu, we have a polynomial of degree 2. We have negative 0.25 alpha squared plus 2 alpha plus 0.5 equals 0, in which case you can see alpha is equal to 8.24, etc. Or we have alpha equals negative 0.24, etc. And because alpha is small, we can therefore conclude that alpha is approximately equal to negative 0.243 given to 3 decimal places. Part B. The point P with coordinates 0, 3 lies on C. We have to find the equation of the tangent to the curve at P, giving an answer in the form y equals mx plus c, where m and c are constants to be found. So, for part B, we have the point P with coordinates 0, 3. With our x coordinate of 0, we can find the gradient of the tangent by substituting in x equals 0 into f dash of x. So f dash of 0, that's equal to 2 multiplied by 0 plus cos of 0 over 2. And because cos of 0 is 1, f dash of 0 then is equal to 1/2. This is the gradient of the tangent, which means then, using the point P, the equation of the tangent is given by y subtract 3 equals 1/2 multiplied by x subtract 0, in which case you will find y to equal x upon 2 plus 3. So we have m equals 1/2 and c equals 3. Question number 5. A continuous curve has equation y equals f of x. The table shows corresponding values of x and y for this curve, where a and b are constants. We've got the values of x, we've got the values of y. The trapezium rule is used with all the y values in the table to find an approximate area under the curve between x equals 3 and x equals 4. Given that this area is 17.59, for part A we have to show that a plus 2b equals 51. Well, here is the trapezium rule. What we are required to find to begin with is h, and that's equal to b, our upper limit, subtract a, our lower limit, over n, the number of pieces of data we have. So, let's find out what h is. From 3 to 3.2, we had 0.2. From 3.2 to 3.4, we had 0.2. From 3.4 to 3.6, we had 0.2. From 3.6 to 3.8, we had 0.2. From 3.8 to 4, we had 0.2. So therefore you can see h is equal to 0.2. And let's label our y values. y0 is a, y1 is 16.8, y2 is b, y3 is 20.2, y4 is 18.7, and y5 is 13.5. So what we can now do is use the trapezium rule to find out what a is and what b is. So for part A, the area that's approximately equal to 1/2 multiplied by h, which is 0.2, multiplied by, well, if we take a look at our table, we've got y0, which is a, and we add on to this y5, which is 13.5, and then we add on 2 multiplied by the values of y in between. So we have 2 multiplied by y1, which is 16.8, plus y2, which is b, plus y3, which is 20.2, plus y4, which is 18.7. So now let's attempt to simplify all this. Well, we have 1/2 times 0.2, that's 0.1. Then we have a plus the 13.5, and then if I do 2 times 16.8, I get 33.6. 2 times b is 2b. 2 times by 20.2, that's 40.4. 2 times 18.7, that's 37.4. And so if I simplify this even further, we end up with 0.1 multiplied by a plus 2b plus 124.9. What I know is that the area is 17.59, so we set this equal to 17.59. And now let's solve and rearrange for a plus 2b. Well, if I have 17.59, and if I divide that by 0.1, and then if I subtract 124.9, what you will find is a plus 2b equals 51, and that's exactly what we wanted to show. Given also that the sum of all the y values in the table is 97.2, we have to find the values of a and b. So what we need to do is add together all these y values. So for part B, the sum of the y's, we've got a plus 13.5 plus 16.8 plus b plus 20.2 plus 18.7, and that simplifies to a plus b plus 69.2. And what we know is that the sum of the y's is equal to 97.2, which means we have a plus b plus 69.2 equals 97.2, and if I subtract 69.2 from both sides, a plus b is equal to 28. Now I've got a plus 2b equals 51 and a plus b equals 28. I can find out what b is by subtracting these equations. A subtract a is 0a, 2b subtract b is 1b, 51 subtract 28 is 23, so b is 23, meaning I have a plus 23 equals 28, which means a is 5. So solving simultaneously, we find a to equal 5 and b to equal 23. Question number 6. A is equal to log base 2 of x and b is equal to log base 2 of x plus 8. We have to express in terms of a and or b the following. For part A, log base 2 of the square root of x. To begin with, we've got a equals log base 2 of x and b equals log base 2 of x plus 8. If we have log base 2 of square root x, what this is equivalent to is log base 2 of x to the power of 1/2. And so if we use the power law of logs, what this is equivalent to is 1/2 multiplied by log base 2 of x. And log base 2 of x is a, so we end up with 1/2 a. For part B, log base 2 of x squared plus 8x. So for part B, we have log base 2 of x squared plus 8x. And what I can do is I can factorise out an x from the x squared and the 8x, leaving me with log base 2 of x multiplied by x plus 8. And using the addition law of logs, what this is equivalent to is log base 2 of x plus log base 2 of x plus 8. Log base 2 of x is a, and log base 2 of x plus 8 is b, so we end up with a plus b. Part C, we have log base 2 of 8 plus 64 over x. So for part C, we have log base 2 of 8 plus 64 over x, and what this is equivalent to is log base 2 of 8x plus 64 over x. I can factorise out an 8 from the 8x and the 64, leaving me with log base 2 of 8 multiplied by x plus 8 over x. I can use the addition law of logs and the subtraction law of logs to simplify this. What we have is log base 2 of 8 plus log base 2 of x plus 8 subtract log base 2 of x. So log base 2 of 8 is 3, log base 2 of x plus 8 is b, and we subtract log base 2 of x, which is a, so we end up with 3 plus b subtract a. Question number 7. The function f is defined by f of x equals 3 plus the square root of x subtract 2, where x is a real number and x is greater than 2. For part A, we have to state the range of f. From our calculator, if we go to the graph sub-menu, let's graph 3 plus the square root of x subtract 2. And if we draw this graph, let's auto zoom. We have a graph which looks something like this. And what you can see is this graph will always be greater than the y value of 3. Which means then, for part A, f of x is greater than 3. This is our range. Part B, find the inverse function of f. To find the inverse function, our first step is to replace the f of x with a y. So we have y equals 3 plus the square root of x subtract 2. We now need to rearrange for x. So if we rearrange for x, well, we would have the square root of x subtract 2 equals y subtract 3, and squaring both sides, x subtract 2 is equal to y subtract 3 squared, and adding 2 to both sides, x is equal to 2 plus y subtract 3 squared. If we now swap the x and y, we end up with y equals 2 plus x subtract 3 squared. And therefore, the inverse is found by replacing y with f inverse, leaving us with the inverse of f is equal to 2 plus x subtract 2 squared. The function g is defined by g of x equals 15 over x subtract 3, where x is a real number and x doesn't equal 3. We have to find g of f of 6. Our first step is to find out what f of 6 is. So we replace x with 6, so we have 3 plus the square root of 6 subtract 2, and if we work this out we get 5. So f of 6 is 5. So therefore, to find g of f of 6, we replace the x with f of 6. So we have 15 over f of 6 subtract 3. And we know what f of 6 is, that's 5. So we have 15 over 5 subtract 3, which is equal to 15 over 2. Part D, find the exact value of the constant a for which f of a squared plus 2 is equal to g of a. To begin with, f of a squared plus 2, we replace the x with a squared plus 2, leaving us with 3 plus the square root of a squared plus 2 subtract 2. So we have 3 plus the square root of a squared, leaving us with 3 plus a. And g of a is quite simply 15 over a subtract 3. So now, if we set f of a squared plus 2 equal to g of a, we would have 3 plus a equals 15 over a subtract 3. So now let's solve this equation. While multiplying both sides by a subtract 3, we would have 3 plus a multiplied by a subtract 3, that's equal to 15. Here we have a difference of 2 squares, so we have a squared subtract 9 equals 15. A squared is equal to 24, and if I square root both sides, a is equal to plus minus 2 times the square root of 6. But because a is greater than 2, and that's implied by the domain of f, we can therefore conclude a is equal to positive 2 times the square root of 6. Question number 8. Figure 1 shows the plan view of a stage. The plan view shows two congruent triangles ABO and GFO joined to a sector OCDEO of a circle centre O, where the angle COE is equal to 2.3 radians. The arc length CDE is equal to 27.6 meters, and AOG is a straight line of length 15 meters. We see all that information summarized in figure 1. For part A, we have to show that OC is equal to 12 meters. So we need to find out what OC is, and you will find OC is the same as OE, which is the radius of the sector. So for part A, if we let R equal OC, which is equal to OE, then the arc length is given by R multiplied by theta. So we've got the arc length 27.6, and this is equal to r multiplied by theta, which is 2.3. And so if we solve for r is equal to 27.6 divided by 2.3, and if we work this out, we get 12. So OC, which is the same as OE, is equal to 12 meters. And if we show this on the diagram, we have OC, which is equal to OE, which is 12 meters. Part B, we have to show that the size of the angle AOB is 0.421 radians, correct to 3 decimal places. So this angle is equal to this angle, and notice we've got angles on a straight line which sum to 180, or equivalently sum to pi radians. So for part B, if we let alpha equal AOB equal GOF, then alpha is equal to pi subtract 2.3 over 2, and if we work this out, it turns out we get 0.4207, etc., which means AOB, which is equal to GOF, is 0.421 radians. And that's given to 3 significant figures. And you can see that added to the diagram here. Given that the total length of the front of the stage BCDEF is 35 meters, we have to find the total area of the stage, giving an answer to the nearest square meter. First of all, you can see that AO is equal to OG, which is half of the 15. So AO equals OG, which is 15 over 2, which is equal to 7.5. So we have AO, which is equal to OG, which is equal to 7.5 meters. We also know that BC is equal to EF, and we know that BCD EF is 35 meters. So with this we can find out what BC is and what EF is. So we have 35 subtract 27.6 over 2, which is equal to 3.7. So we have 3.7 for BC and 3.7 for EF. So therefore, OB and OF, which are the same, will be the sum of the 12 and the 3.7. So OB equals OF, which is equal to the 3.7 plus the 12, which is 15.7. We now have enough information to work out the total area. We know that the triangle ABO and the triangle GFO are congruent, meaning the areas of those will be the same. And we have enough information to work out those areas. So the area of ABO, which is equal to the area of GFO, that's equal to a half times by the 7.5 times the 15.7 times by the sine of the 0.421. So let's work this out. We've got a half times by 7.5 times by 15.7 times by the sine of the 0.4207, etc. So it turns out the area is equal to 24.06 meters squared. We can now find the area of the sector. We know the radius and we know the angle. So the area of the sector, that's given by a half times by r, which is 12. Then we square this, multiplied by the 2.3. So we've got a half times by 12 squared times 2.3, which is 165.6. So the total area, we've got 2 times by the area of each triangle, and then we add on the area of the sector, and if we work this out, we get 214 meters squared to the nearest square meter. Question number 9. The first 3 terms of a geometric sequence are 3k plus 4, 12 subtract 3k, k plus 16, where k is a constant. For part A, we have to show that k satisfies the equation 3k squared subtract 62k plus 40 equals 0. To begin with, for part A, the common ratio r, that's equal to the second term divided by the first term, and this is also equal to the third term divided by the second term, and this is true for a geometric sequence. We know what the first, second and third terms are, which means we can find an equation in terms of k. So we've got u2, which is 12 subtract 3k, divided by u1, which is 3k plus 4, and this is equal to u3, which is k plus 16, divided by u2, which is 12 subtract 3k. Let's rearrange this. So we have 12 subtract 3k multiplied by 12 subtract 3k, which is 12 subtract 3k squared, and this is equal to the 3k plus 4 multiplied by the k plus 16. If we simplify the left hand side, we end up with 9k squared subtract 72k plus 144, and on the right hand side, if we simplify the right hand side, we end up with 3k squared plus 52k plus 64. And if we rearrange by taking everything over to the other side, we end up with 6k squared subtract 124k plus 80, and this is equal to 0, and if I divide through by 2, you will find 3k squared subtract 62k plus 40 is equal to 0, and that's exactly what we wanted to show. Given that the sequence converges, for the first part of part B, we have to find the value of k, giving a reason for your answer. We know so far that 3k squared subtract 62k plus 40 equals 0, and with this we can find out the possible values of k. If we factorize, we end up with 3k subtract 2 multiplied by k subtract 20 equals 0. And if I solve for k, you will find k to equal 2/3 or k to equal 20. And with these values of k, what we can do is find the value of r. We know that r is the same as 12 subtract 3k over 3k plus 4, and r is also equal to k plus 16 over 12 subtract 3k. So with our values of k, we can find the values of r. So if k is 2/3, then r, which is k plus 16 over 12 subtract 3k, that's equal to 2/3 plus 16 over 12 subtract 3 times 2/3, which is 5 over 3. And if k is 20, r, which is equal to k plus 16 over 12 subtract 3k, that's equal to 20 plus 16 over 12 subtract 3 times 20. And if we work this out, we get negative 3 over 4. So which value of k do we use? Do we use the k equals 2/3 or do we use the k equals 20? Well, we know that the sequence converges when the mod of r is less than 1. And if I compare the 5/3 with the negative 3/4, the negative 3/4 is the value of r we require for convergence, and that corresponds to k equaling 20. Which means then k is equal to 20. For the second part of part B, we have to find the sum to infinity. Well, what we know is the sum to infinity, that's equal to a, the first term, over 1 subtract r, where r is the common ratio, and the mod of r is less than 1. So we know that the first term is given by 3k plus 4. So finding out the first term, a is equal to 3k plus 4. So we have 3 multiplied by 20 plus 4, which is 64. The common ratio, that's negative 3/4, that is found by substituting in k equals 20. So the sum to infinity, that's equal to a, 64, divided by 1 subtract the common ratio, so we have 1 subtract negative 3/4, and working this out, we get 256 over 7. So the sum to infinity is 256 over 7. Question number 10. A circle C has equation x squared plus y squared plus 6kx subtract 2ky plus 7 equals 0, where k is a constant. For part A, we have to find in terms of k the coordinates of the centre of C and the radius of C. So for part A, we begin with our equation x squared plus y squared plus 6kx subtract 2ky plus 7 equals 0. If we complete this square for the x's, well, halving the coefficient of x, we end up with 3k, so we have x plus 3k all squared, and then we subtract the square of 3k, which is negative 9k squared, and in terms of the y's, half of the negative 2k is negative k, so we have y subtract k all squared, and then we subtract the k squared, and then we add the 7, and this is equal to 0. And if we simplify, we have x plus 3k squared plus y subtract k squared, and then this is equal to, well, here we've got negative 9k squared, subtract another k squared plus 7, so that's negative 10k squared plus 7, and moving that over to the right hand side, we end up with 10k squared subtract 7. So the centre will have coordinates negative 3k, k, and the radius will be given by the square root of 10k squared subtract 7. The line with equation y equals 2x subtract 1 intersects C at two distinct points. We have to find the range of possible values of k. So what we have is this line y equals 2x subtract 1, and it intersects C at two distinct points. So here is a diagram of the circle C with this straight line y equals 2x subtract 1, and it intersects C at two distinct points. So we have x squared plus y squared plus 6kx subtract 2ky plus 7 equals 0, and we know that y is equal to 2x subtract 1. So we have x squared plus y squared, so we add on 2x subtract 1 squared, then we add on 6kx, then we subtract 2k multiplied by 2x subtract 1 plus 7, and this is equal to 0. So I have x squared, and if I expand 2x subtract 1 all squared, I end up with 4x squared subtract 4x plus 1, then I add on the 6kx, negative 2k multiplied by 2x, that's negative 4kx, negative 2k multiplied by negative 1 is positive 2k, I add the 7, and this is equal to 0. So I've got x squared plus 4x squared, that's 5x squared, then I've got negative 4x plus 6kx, subtract 4kx, that's negative 4 plus 2kx, and then I've got the 1 plus the 2k plus the 7, that's 8 plus 2k, and this is all equal to 0. So We know that the discriminant is greater than 0 because the line L1 meets the circle at two distinct points. So we've got b squared subtract 4ac as our discriminant. So we've got negative 4 plus 2k squared subtract 4 times by 5 times by 8 plus 2k. This is greater than 0. So negative 4 plus 2k squared, that's 16 subtract 16k plus 4k squared. Then here I've got negative 4 times 5 multiplied by 8, which is negative 160. Then I've got negative 4 times 5 times by 2k, that's negative 40k. This is all greater than 0. And if I simplify this and divide through by 4, we end up with k squared subtract 14k subtract 36 is greater than 0. Let's now attempt to complete the square. I've got k subtract 7 squared subtract the square of 7, which is 49, subtract the 36 being greater than 0. So I've got k subtract 7 squared subtract 85 is greater than 0. So my critical values, I would have 7 plus minus the square root of 185, which means then for my solutions, I've got k being less than 7 subtract square root 85 and k being greater than 7 plus square root 85. These are my solutions. Question 11. The value £v of a mobile phone t months after it was bought is modelled by v equals ab to the t, where a and b are constants. Figure 2 shows the linear relationship between log base 10 of v and t, and the line passes through the points 0, 3 and 10, 2.79. Part A. Using these points, we have to find the initial value of the phone. For us to find the initial value of the phone, we need to find out what the value v is. We know along the log base 10v axis, the line passes through 0, 3, which means we have log base 10 of v equals 3, and we need to find out what v is. So v is equal to, if we antilog, 10 to the power of 3, which is 1,000, which means the initial value is £1,000. Part B, we have to find a complete equation for v in terms of t, giving the exact value of a and giving the value of b to three significant figures. Part B, we begin with v equals ab to the power of t, and if we take log base 10 of both sides, we have log base 10 of v, which is equal to log base 10 of ab to the t. On the right hand side, we can split up log base 10 of ab to the t using the addition law of logs. So we have log base 10 of a plus log base 10 of b to the t. And we can simplify further this log base 10 of b to the t using the power law of logs. So we have log base 10 of v equals t multiplied by log base 10 of b plus log base 10 of a. This is of the form y equals mx plus c. So if we consider the point 0, 3, we've got a t coordinate of 0 and a log base 10 of v coordinate of 3. So we have 3 equals 0 multiplied by log base 10 of b plus log base 10 of a. So we have 3 equals log base 10 of a, which means a is 1000. And if a is 1000, that means we have log base 10 of v equals log base 10 of 1000, because that's what a is, plus t multiplied by log base 10 of b. And log base 10 of 1000 is 3. So we have log base 10 of v equals 3 plus t multiplied by log base 10 of b. We also have this other point on the line, 10, 2.79. And if we substitute this t coordinate of 10 and this log base 10 of v coordinate of 2.79 into this equation, we have 2.79 equals 3 plus 10 multiplied by log base 10 of b. So what we need to do is find out what b is. So we have 2.79 subtract 3 divided by 10. We end up with negative 0.021, which means log base 10 of b is equal to negative 0.021. And if we anti-log to find out what b is equal to 10 to the power of negative 0.021. So we have 10 to the power of negative 0.021, which is 0.952, etc., which means b to three significant figures is 0.953. And as v is equal to ab to the power of t, we can therefore conclude v is equal to 1000 multiplied by 0.953 to the power of t. Exactly 2 years after it was brought, the value of the phone was £320. We have to use this information to evaluate the reliability of the model. So if we think about t is in months. We're looking at the value of the phone after 2 years, so that's 24 months. So for part C, when t is equal to 24, we have v equals 1000 multiplied by 0.953 to the power of 24. So let's work this out. We have 1000 multiplied by this value of b to the power of 24. It turns out we get 313.328, etc. So let's work out the percentage error. The percentage error is given by 320, the actual value, subtract the 313.328, etc. of the 313.328, etc. multiplied by 100. So, working this out, we have 320, subtract the 313 over the 313, and if I multiply this by 100, we end up with 2.129, etc. %. So the model is reliable. Question number 12. We're given that y is equal to sin x, where x is measured in radians. We have to use differentiation from first principles to show that dy over dx is equal to cos x. You may use without proof the formula for the sine of a plus minus b and assume that as h tends towards 0, sin h over h tends towards 1, and cos h subtract 1 over h tends towards 0. Here is the formula for first principles. F dash of x, or in our case dy over dx, that's equal to the limit as h tends towards 0 of f of x plus h subtract f of x over h. So dy over dx, that's equal to the limit as h tends towards 0 of, well, here we replace x with x plus h, so we have the sine of x plus h, and then we subtract sin x, and then we divide this by x plus h subtract h. Now, for us to deal with the sine of x plus h, we have to use the formula for sine of a plus minus b. And the formula for sine of a plus minus b is equal to sine a cos b plus minus cos a sine b. So, we've got the limit as h tends towards 0 of sine of x plus h, which is the same as sin x cos h plus cos x sin h, and then we subtract sin x, and then we divide this by x plus h subtract h, so we just divide by h. So, we have the limit as h tends towards 0, and what I'm going to do is think about the terms involving sin x only. I've got sin x, cos h, subtract sin x, and if I factorise out a sin x, I would have cos h subtract 1 multiplied by sin x, and then we've also got this term here, the sin h multiplied by the cos x, and then I divide this by h. So let's simplify this even further. What I have is the limit as h tends towards 0 of cos h subtract 1 over the h multiplied by sin x, and then I add on to this the limit as h tends towards 0 of sin h over h multiplied by cos x. So if we work through this, we've got the limit as h tends towards 0 of cos h subtract 1 over h multiplied by the sin x, plus the limit as h tends towards 0 of sin h over h multiplied by cos x. And what we have to do is use these results here. We know that as h tends towards 0, cos h subtract 1 over h tends towards 0, and we multiply this by sin x, and we know that as h tends towards 0, sin h over h tends towards 1. So we have 1 multiplied by the cos x. And if we simplify this, we end up with cos x, which means the differential of sin x is cos x. Question number 13. On a roller coaster ride, passengers travel in carriages around a track. On the ride, carriages complete multiple circuits of the track such that the maximum vertical height of a carriage above the ground is 60 meters. A carriage starts a circuit at a vertical height of 2 meters above the ground. The ground is horizontal. The vertical height, h meters, of a carriage above the ground, t seconds after the carriage starts the first circuit, is modelled by the equation h equals a subtract b multiplied by t minus 20 squared, where a and b are positive constants. For part A, we have to find a complete equation for the model. Now, the equation that's given to us is in complete the square format. And what we can do with this is find out the maximum coordinates. The maximum coordinates occur at 20a. We know from the question the maximum vertical height of a carriage above the ground is 60 meters, which then means we have a maximum a equaling 60, which means h is equal to 60 subtract b multiplied by t minus 20 squared. What we also know is a carriage starts a circuit at a vertical height of 2 meters above the ground, which means when t is 0, h is 2. So if I substitute these into my equation, I have 2 equals 60 subtract b multiplied by 0 minus 20 squared. So I have 400b equals 58, and if I attempt to find out what b is, 58 divided by 400 is 0.145, which means b is equal to 0.145. And knowing what a and b are, we can therefore conclude h is equal to 60 subtract 0.145 multiplied by t minus 20 squared. Part B, we have to use the model to determine the height of the carriage above the ground when t is equal to 40. When t is equal to 40, I replace the t with 40, so I have h equals 60 subtract 0.145 multiplied by 40 subtract 20 squared. So I have 60 subtract 0.145 multiplied by 40 subtract 20 squared. Turns out we get 2, which means h is equal to 2. In an alternative model, the vertical height h meters of a carriage above the ground t seconds after the carriage starts the first circuit is given by h equals 29 multiplied by the cosine of 90 plus alpha degrees plus beta, where alpha is in between 0 and 360 degrees, and alpha and beta are constants. For part C, we have to find a complete equation for the alternative model. So for part C, we have h equals 29 multiplied by the cosine of 90 plus alpha degrees plus beta. And we know that the maximum of the cosine of 9 alpha plus 1 degrees is equal to 1. And we know from the question that the maximum height is equal to 60. Which means then the largest value of h is 60. So we have 60 equals 29 multiplied by 1, because this is where we have a maximum, plus beta. And with this equation, we can conclude beta is equal to 31. So with beta equaling 31, we can conclude h is equal to 29 multiplied by the cosine of 90 plus alpha plus beta, which is 31. And we also know one of the other conditions we have is t is 0, h is 2. So using that, we have 2 equals 29 multiplied by the cosine of 0 plus alpha plus 31. And if I rearrange, we end up with the cosine of alpha equals -1, which means alpha is 180 degrees. And knowing what alpha is, we can therefore conclude h is equal to 29 multiplied by the cosine of 90 plus 180 degrees plus the 31. Given that the carriage moves continuously for 2 minutes, that in seconds is 120 seconds, you have to give a reason why the alternative model would be more appropriate. So we're looking at why this model is more appropriate. So for part D, with Model 1, Model 1 only has the carriage above its starting position for 40 seconds. And that's because of the shape of the quadratic. And so therefore, we cannot model 120 seconds of movement, whereas with Model 2, that uses a periodic function with the carriage always at least as high as its starting position, which is why we use Model 2. Question number 14, we have to prove using algebra that n plus 1 all cubed subtract n cubed is odd for all n belonging to a set of natural numbers. So we begin with n plus 1 cubed subtract n cubed. Now the n plus 1 cubed, that's equivalent to n cubed plus 3n squared plus 3n plus 1. And then we subtract from this n cubed. Now the n cubed and the negative n cubed simplify to 0, leaving us with 3n squared plus 3n plus 1. Now what we want to do is show that this is odd. Now we know that the 1 is odd, so if I somehow show that the 3 times by the n squared plus 3n is even, we'd have even plus odd, which is odd, and that's what I want to show. So let's think about how we can do this. Well, the 3n squared and the 3n, they have a 3 as a common factor and an n as a common factor, and what goes inside the bracket is n plus 1. 3n times by n plus 1 is the same as 3n squared plus 3n, and then we add on this 1. Now if I think about the n times by n plus 1, that's the product of two consecutive integers. And the product of two consecutive integers, that's always even. If I think about two consecutive integers, for example 4 and 5, or 7 and 8, or 21 and 22, or 105 and 106, the product of those will always be even because we've got an odd number times by an even number. So n times by n plus 1 is always even. So if I have n times by n plus 1 being even, and I'm multiplying that by 3, 3 times by n plus 1 will always be even. So we have 3 times by n plus 1, which is even, and I'm adding 1 to this. And if I add the 1 to this, I've got even plus odd, which is odd, which means n plus 1 cubed subtract n cubed is odd for n belonging to a set of natural numbers. Question number 15. A curve has equation y equals f of x, where f of x is equal to 7x e to the x over the square root of e to the 3x subtract 2, where x is greater than the natural log of the cube root of 2. We have to show that for part A, f dash of x is equal to 7e to the x multiplied by e to the 3x multiplied by 2 subtract x plus ax plus b all over 2 multiplied by e to the 3x subtract 2 to the power of 3 over 2, where a and b are constants to be found. Now here we have a function being divided by another function, and we are required to differentiate that. And so what we'd have to use is the quotient rule. If we differentiate f over g, the result of that is f dash g subtract f g dash over g squared. So for part A, if we let y equals 7x e to the x over e to the 3x subtract 2 to the power of 1/2, where raising something to the power of 1/2 is the same as square rooting, we can define u to equal 7x e to the x. So u dash is equal to 7x multiplied by the derivative of e to the x, which is e to the x, and we add on to this e to the x multiplied by the derivative of 7x, so we add on 7e to the x. V is equal to e to the 3x subtract 2 to the power of 1/2, and if we differentiate this using the chain rule, v dash is equal to, well, we have the 1/2 and we multiply this by e to the 3x subtract 2, and then we subtract 1 from the power, so we have negative 1/2, and then we multiply by the differential of the bracket, so we multiply by 3e to the 3x, and if we simplify all this, we end up with 3 over 2 e to the 3x multiplied by e to the 3x subtract 2 to the power of negative 1/2. So therefore, dy over dx, we have v multiplied by u dash subtract u multiplied by v dash, and then we divide this by v squared, so we divide by v squared as we see here. And what we are required to do at this point is simplify all of this. And the way we're going to simplify this is to multiply each term by e to the 3x subtract 2 to the power of 1/2, and this will get rid of this negative 1/2 power. So we have this e to the 3x subtract 2 to the 1/2 multiplied by 7x e to the x plus 7 e to the x, and we'll multiply this by e to the 3x subtract 2 to the half, and then I subtract the 7x e to the x multiplied by 3 to the 1/2 e to the 3x multiplied by e to the 3x subtract 2 to the negative 1/2, and we'll multiply this by e to the 3x subtract 2 to the 1/2, and then I divide this by the e to the 3x subtract 2 to the 1/2 squared by e to the 3x subtract 2 to the 1/2. So let's simplify this. Well, here I have e to the 3x subtract 2 to the half multiplied by e to the 3x subtract 2 to the 1/2, so that's just e to the 3x subtract 2, and I'm multiplying this by the 7x e to the x plus 7e to the x, and then I subtract from this. Well, here I've got 7x e to the x times by 3 over 2 e to the 3x, and then I've got this e to the 3x subtract 2 to the negative 1/2 being multiplied by e to the 3x subtract 2 to the 1/2. This product gives us 1, leaving us with 21 over 2, because I've got 7 times 3 over 2, x to the ex multiplied by e to the 3x. And then I divide this by, well, here I've got a half raised to the power of 2, such as 1, and I'm multiplying that by something raised to the power of 1/2, leaving me with e to the 3x subtract 2 to the power of 3 over 2. And now we need to simplify all this. So what I've done over here is bring this 2 into the denominator, and in doing so I have to multiply this term by 2, leaving me with 2e to the 3x subtract 4 multiplied by 7x e to the x plus 7e to the x subtract 21x e to the x e to the 3x over 2 multiplied by e to the 3x subtract 2 to the power of 3 over 2. And notice 2e to the 3x subtract 4 over 2 gives e to the 3x subtract 2. And notice negative 21 over 2 is what we have here. And the reason I want to do this, if I go back to the question, here I've got a 2 in the denominator. So let's simplify this even further. If I factorise out a 7e to the x from each term, then inside the bracket, I've got this 2e to the 3x subtract 4, and then inside this bracket I'd have x plus 1. And notice if I multiply 7e to the x by x plus 1, I get 7x e to the x plus 7e to the x. And then I subtract 3x e to the 3x, because 7e to the x multiplied by 3x e to the 3x gives 21x e to the x e to the 3x. And then I divide this by 2 multiplied by e to the 3x subtract 2 to the power of 3 over 2. So if I work this out, I've got 7e to the x, and then I've got 2e to the 3x multiplied by x, which is 2x e to the 3x. Then I've got 2e to the 3x multiplied by 1, which is 2e to the 3x. Then I've got negative 4 times by x, which is negative 4x. Then I've got negative 4 times by 1, which is negative 4. And then I subtract 3x e to the 3x. And then I divide this by 2e to the 3x subtract 2 to the 3 over 2. So I've got the 7e to the x, and then inside this bracket I've got 2e to the 3x subtract x e to the 3x, because I've got 2x e to the 3x subtract 3x e to the 3x, which is negative x e to the 3x. And then I've got this negative 4x, and then I've got this negative 4. And then divide this by 2 multiplied by e to the 3x subtract 2 to the 3 over 2. So I've got 7e to the x, and inside this bracket, if I factorise out an e to the 3x, then inside this bracket I have 2 subtract x, so I factorised out an e to the 3x from this term and this term. Then I subtract 4x and subtract 4, and I divide this by 2 multiplied by e to the 3x subtract 2 over 3 over 2. So you can see then a is negative 4 and b is negative 4. Part B, hence show that the x-coordinates of the turning points of the curve are solutions of the equation x equals 2e to the 3x subtract 4 over e to the 3x plus 4. Well, what I need to do for part B, I've got f dash of x, which is shown here, and because I'm considering the x-coordinate of the turning points, I need to set f dash of x equal to 0, as we see here. And if that's the case, then, solving this equation equal to 0, I've got 7e to the x multiplied by e to the 3x multiplied by 2 subtract x subtract 4x subtract 4 equals 0. So I've got the 7e to the x, which cannot equal 0, which leaves me with e to the 3x multiplied by 2 subtract x subtract 4x subtract 4 equals 0. So now let's solve this. Well, I've got 2 times e to the 3x, which is 2e to the 3x, e to the 3x subtract x. The product of those gives me negative x e to the 3x. Then I've got this negative 4x and negative 4, and this is equal to 0. So now I've got 2e to the 3x subtract 4, that's equal to x e to the 3x plus 4x, and if I factorise out a x from the right hand side, I've got x multiplied by e to the 3x plus 4. And if I divide both sides by e to the 3x plus 4, I end up with x equals 2e to the 3x subtract 4 over e to the 3x plus 4. The equation x equals 2e to the 3x subtract 4 over e to the 3x plus 4 has two positive roots, alpha and beta, where beta is greater than alpha. A student uses the iteration formula xn plus 1 equals 2e to the 3xn subtract 4 over e to the 3xn plus 4 in an attempt to find approximations for alpha and beta. Diagram 1 shows a plot of part of the curve with equation y equals 2e to the 3x subtract 4 over e to the 3x plus 4 and part of the line with equation y equals x. Using diagram 1, we have to draw a staircase diagram to show that the iteration formula starting with x1 equals 1 can be used to find an approximation for beta. So here is diagram 1. We start off with x1 equaling 1, and then we go to the curve, then we go to the line, then we go to the curve, then we go to the line, then we go to the curve, then we go to the line, and eventually we converge towards x equals beta. Use the iteration formula with x1 equaling 1 to find to 3 decimal places the value of x2 and then the value of beta. For part D, here is our iterative formula. We are starting off with x1 equaling 1. So x2, that's equal to 2e to the 3x1 subtract 4 over e to the 3x1 plus 4. So if I work this out, I've got x1 equaling 1. So I've got 2e to the 3 times 1 subtract 4 over e to the 3 times 1 plus 4. So on our calculator, if I press 1, which is the value of x1, and press equals, let's type this iterative formula, but replacing xn with the answer function. So I've got 2, then I have e to the 3 times by this answer, subtract 4, over e to the 3 times by this answer, plus 4. So solving to 3 decimal places, I see that x2 is equal to 1.501. And now for me to find beta, let's continue off this calculation as we see here. And if we continue off the calculation, eventually we see that we have beta equaling 1.968. Using a suitable interval and a suitable function that should be stated, for part A we have to show that alpha is equal to 0.432 to 3 decimal places. So for part A, we begin with x equals 2e to the 3x subtract 4 over e to the 3x plus 4. And I'm going to rearrange this so I have something equal 0. So I have 2e to the 3x subtract 4 over e to the 3x plus 4 subtract x equals 0. And the reason this is important is because now I can state what my suitable function is going to be. G of x, my suitable function, that's going to equal 2e to the 3x subtract 4 over e to the 3x plus 4 subtract x. So we're going to be considering values between 0.4315 and 0.4325. The reason is we want to show that alpha is equal to 0.432. So I'm considering the lower bound and the upper bound. So let's begin by working out g of 0.4315. What we have is 2 multiplied by e to the power of 3 times by 0.4315 subtract 4 over e to the power of 3 times by 0.4315 plus 4 subtract 0.4315. So it turns out we get negative 0.29 etc. times 10 to the negative 4, which is less than 0. And if I consider g of 0.4325, if we work out what this is equal to, we end up with 9.4 etc. times 10 to the negative 4. So what we see then is g of x is continuous and we've got a change in sign. We're going from negative to positive in this interval, which means our root must be in between 0.4315 and 0.4325, and therefore if I solve for alpha, you can see alpha is equal to 0.432 to 3 decimal places.